Recently, we've been talking about energy, and we've learned that there's two basic types, kinetic energy and potential energy. Potential energy being the energy that's stored up in an object, whether that's based on its height or what it's made of, and kinetic energy being energy that's with an object that's moving. And I thought we'd take a look at those today using these energy tracks. So let's go ahead and do that.
What we have here is two identical tracks that both start and stop at the same height. Now, I want you to take a guess what's going to happen when I start with these two metal balls and release them from the same point, same height on this side. Alright, let's take a look. Alright, we saw that this one returned back to this side much quicker than this one. So why is that? Now, these are both starting and stopping at the same heights, so they are at the same height. But this one has to cover much more distance. So why would this one be faster? Let me just show you that real quick. So this top track measures to be 116 centimeters, and the low track measures to be 122. Here's an up-close view of what's going on here. So I'll start them at the same height. And again, we see that the low track ball made it back to this side before the high track ball. Now, what's actually going on here? Well, we learned about the principle of conservation of energy, and that said that energy cannot be created or destroyed, but it can be changed. So what's happening is these metal balls are starting out, right now on the table they have zero potential energy. But I give them some of my energy, and I lift them up to a higher place. So I gave them some potential energy. When I let go, that potential energy can be changed into kinetic energy, which basically just gets the ball rolling. Now we see that for the low track ball, that got more of its potential energy converted into kinetic energy. And so the reason it makes it back faster is because it spent this portion of the track going a faster speed than this ball. Now let's see what would happen if we try to change this up. What if the ball went up again and then back down? Would that slow the ball down enough to make this one faster now? The setup for this one is similar. We have two tracks, the same height, start and end. On this one, there's one that stays high, but in this case, we have a hill in the middle. So it's not just going down to the bottom and then coming back up. It's going down, then back up, then down, and then back up. So let's see if that makes a difference. I'd like to take a look up close and see if we can see a little better what's going on with these balls. So here it is again, starting at the same height. And I think we saw that this one was first again. Now, what about the same track as we saw the first time with one low track, no hill in the middle, and one high track? The only difference between this one and the first one is that these are up at a lot higher height, and there's a lower dip in the middle on the low track. So let's take a look at how these go. Starting at the same height, I think we saw that, again, the low track wins over the high track. Really, the main difference between this track and the first track we saw is the height. We already said that. So the only difference in the energy, it's not changing any different than the first one, but there is more energy. So I am giving this ball more potential energy in the beginning, that it is allowed to convert that into kinetic energy, and so the ball goes faster and it has more energy to burn. And it does go a little bit longer too, it seems. Now there was another thing that we can look at with these tracks too. We talked earlier about PoCoE, and that said energy cannot be created or destroyed. Well, let's take a look at that now. So if I start this ball on this side of the track at a certain height, the ball cannot go any higher than the starting height on this side of the track because energy is not created. It's also not destroyed too, and that just means it doesn't just vanish, it goes somewhere. So in this case, might be kind of hard to hear, but this ball is making a sound, so it's producing sound energy, and there's a little bit of friction in this track. So that is causing the track to heat up slightly and the ball to heat up slightly. That's why the ball is stopping. Now, while playing around with this, I did find out that it is possible to add energy to the system, but I have to do it. The ball cannot add its own energy. So for example, if I pull on this the correct way when the ball is traveling, I can get the ball to go over the hump. Now I want to leave you with this last track. I want you to make a prediction at the end of this. I'm going to start the balls at the same spot, and since these tracks are identical, they should hit at the same time. And we see that they do. Now what's weird about this track is, no matter where I start each of the balls, they will hit the bottom at the same time. So watch this. The exact same time. I can flip it. I'll do E and B right here. I'll even do one F and A. Now I want you to see if you can come up with an explanation as to why this is happening. Think about what we've talked about in class. Which one of these balls has the highest potential energy at the start? Think about how kinetic and potential energy are related, and they can change form from one form to another. And how does PoCoE help explain any of this? See if you can try to come up with your own explanation as to why this is happening.